Good morning or good evening, my YouTube viewers. It's Crystal here. I'm just here because I want to do a code review with you, and basically, this is a Jupyter notebook that I developed today, and I just wanted to say that I'm not going to be able to produce videos and blog posts as quickly as I have in the past, and the reason why is because I'm studying TensorFlow, and while I'm studying, I'm looking at other people's code, but when I do a code review or a blog post, I have to use pretty much my own code, something that I've done myself, so it's going to take me longer to produce my own code because I'm studying TensorFlow and there's lots to learn in TensorFlow. So basically what I'm going to do in this particular code review, it's an A to Z handwritten alphabet in a CSV format, and it's similar to the MNEST dataset. So if you've done the MNEST dataset, or if you have done the Fashion MNEST dataset, then you'll have a pretty good idea what this CSV file is all about. So I downloaded the code from Kaggle, and it's the A to Z written alphabets dot in CSV format. So if you want to do it yourself, you know which data set that I used in Kaggle. I put my Jupyter notebook in GPU format, so it would run faster. The problem statement is, I made the problem statement, so this data set is similar to the MNEST data set, except it has alphabet except numbers. So I'm not going to edit that. I'll just leave that as it is, because if I edit it, then I'll have to resave it, and it takes about 10 minutes to resave it. And so obviously 10 minutes is an incredibly long time, but I spent a long time working on this data set today because I wasn't really sure what I was doing. And so in order for me to get it to work, I had to do a lot of experimentation, but I finally did get it to work in the end. So I created this Jupyter notebook in Kaggle, and so if you have a Kaggle account, you can create a Jupyter notebook too. My data set is public. My Jupyter notebook is public, so you can go onto my Jupyter notebook and look at it as well. So first thing we're going to do is we're going to import the libraries, and as I said, this is very similar to the MNEST dataset, but it's A to Z instead of 0 to 9. So when we import our libraries, we're going to import NumPy as NP, which is for numerical computations. We're going to import Pandas as PT, which is for data processing. We're going to import OS, which is the operating system. It'll go into the computer and retrieve the files. We're going to import matplotlib.pyplot as PLT, which is for data visualization, and we're going to import Seaborn as SNS, which is also for data visualization and is written on the back of Matplotlib. Then we're going to load our files. So the file that we've got, I don't know why is the bottom one. That's the file that we're using. The top one, it didn't work when I tried to upload it, but we use OS to upload the files. And then what we're going to do is we're going to use Pandas to read the file, and the header is none. So data equals pd.read underscore CSV, then the web address or the path to the file, and header equals none. You have to set it up for header equals none. And then you can see the data set. The data set is 372,451 rows by 85 columns. So you've got 784 columns, really, which are like one hot encoded. And this one hot encoding tells you the letters, okay? And column 0 is 0 to 25, which is your 26 letters in the alphabet. So we're going to define the target. So target equals data.iloc brackets :, 0. And so what that's saying is that the target is the 0 column. That's your labels. And then we're going to define the data. So your target is your Y variable and your data is your X variable. And the data is data.iloc brackets : 1 : And so what that's doing is that's telling you that the data is row 1 to row 284. So we've got our data as well. We're going to analyze the target with Seaborn. And you can see we've got all these different letters in the alphabet. And it tells you which letters are more prolific than others. So like letter 14 is the highest frequently occurring letter. So A, B, C, D, E, F, G, H, I, J, K, L, M, N. So I think that's M or N. M or N is your most frequently occurring letter. And then like letter 18 is frequently occurring and letter 20 is frequently occurring. So you can figure out for yourself which letters are the most frequently occurring letter. And then we do a value counts. And so that's telling you how many times each letter occurs. So letter number 0 is A, occurs 13,870 times. And 1, which is B, occurs 8,668 times. And you can go on down the line to find out how many times each letter occurs. Now what I did was I did the class names. I didn't actually use that, but I suppose if I had wanted to, I could have created a dictionary with 0A, 1B, 2C, all the way down to 25Z. But I didn't do that. I didn't do anything with class names. So class names is just sitting in there. But if you want to do something with class names, you're more than welcome. And so what I wanted to do is I wanted to visualize a number. So I picked out row 350,000, and row 350,000 is X, and its labeled class is 23. And so you can play around with that and pick a number, a row, and you can print the row because the row is associated with a letter in the alphabet. So I reshaped the every row in the data frame. So reshape df equals data.values.reshape data.shape 0, which that's the number of the rows, 28. So you're going to convert it from a 2-dimensional array to a 3-dimensional array. And then data equals reshape df, print len data, that's 372,451, and print data shape, that's 372,451 by 28 by 28. So what I did was I reshaped it. So instead of having a 2-dimensional matrix or array, I now have a 3-dimensional array. And obviously, I'm still new at this, and I'm new at this, and so maybe I didn't do it exactly the way somebody else should have done it. But hey, I did it. At least now you know how to reshape data. I use sklearn's train test split to split the data into training and validation sets. And I use the data in the target, set the test size up for 0.2, random state equals 42, shuffle equals true because I wanted to shuffle the data. So you've got X train, X val, Y train, Y val, and then you've got the shapes. So it says create CNN, which it's not a CNN, it's a DNN. I wanted to I wanted to make a CNN, and I tried all day to make a CNN, and finally I don't know enough to make a CNN, so I made it a DNN. So it's a DNN, not a CNN. And so we imported TensorFlow as TF, and we print our version of TensorFlow, which is 2.11.0, which is interesting because I was trying to do natural language processing, and I couldn't get the TensorFlow to be anything other than 2.3, and so I put a message on the message board of that particular competition. And I don't know if they went and uploaded it to the most recent version or not, but today it's 2.11, and then a few days ago it was 2.3, so I don't know, maybe the message that I put in had something to do with it. But I will say this about TensorFlow, we're on version 2.11, but I believe that there's even a version 3 of TensorFlow. And TensorFlow keeps changing. It's always changing. And so, like, you could have programmed something a year or two in TensorFlow, and because the program is changing, or the language is changing, or the library is changing, the code that you have written a year or two ago may very well be deprecated. So that's a problem that I personally have seen regarding TensorFlow. Like, I'm taking a course on TensorFlow with Allison, and it's a free course. And basically, it's TensorFlow 2. Well, that's what they're teaching on. And so actually the course itself is obsolete, but I'm going ahead and completing the course, thinking that maybe I'll learn something. And then so I look on the course, and then I go into the TensorFlow tutorials and study the TensorFlow tutorials. So I spend a lot of time studying code, and because I'm studying code, I'm not really able to write that much code at the moment because TensorFlow has a pretty good sized learning curve. And that's another reason why I'm not making as many videos and doing as many blog posts, because I'm spending so much time studying. So now that we talked about TensorFlow, we got our DNN. It's not a CNN, it's a DNN. So model equals tf.keras.models sequential, tf.keras.layers flatten. Input shape is 28 by 28, so we flattened it. tf.keras.layers.dense is 128, and activation is ReLU. tf.keras.layers dropout is 2, and tf.keras.dense is 26 because there's 26 outputs. So I imagine I could do more to improve my score, but since I'm still learning, I'm not sure exactly what that is. So we set up our loss fn equals tf.keras.losses sparse categorical cross entropy from logits equals true, and then we compile it. Model.compile brackets optimizer equals atoms, loss equals loss underscore fn, and metrics equals accuracy. And then we fit the model. So model.fit X train Y train, and I set it up for 10 epochs because I didn't want to spend a lot of time training it. But you can set it up for more epochs. But if you set it up for too many epochs, then you run the risk of overfitting. But I just used 10 epochs because I wanted to get it done quickly. Then we evaluate the model.evaluate xval, yval, verbose equals 2. So that means you can see what it does. Test loss, test accuracy equals model.eval, xval, yval, verbose equals 2. And that's another thing that I should have done. I should have said val loss, val accuracy, but I didn't. So it's 80% accuracy. So make predictions. Ypred equals model.predict xval. Ypred equals ypred flatten. Ypred equals np argmax. Model.predict xval. Axis equals -1. Ypred. So we made our predictions, so you can see the predictions, and we flattened it. So we checked the accuracy, and again, we got 80% accuracy. So I can see doing this code review, I can see where there's some things that I need to change, just minor things. So I probably will go ahead and change it after I've completed this code review, just to make sure it's correct. Now we put it on a confusion matrix, so you can see the confusion matrix. And then we compare the actual values to the predicted values. So you can see how the actual values line up with the predicted values. And that's all. That's it for the code review. And the reason why that's it for the code review is because it's not a competition. Because it's not a competition. I didn't do it for the test set. But since I've got you here, I'll go ahead and edit it while you're here. So it's not a CNN. It's a DNN. I wanted it to be a CNN, but I don't know enough to. I have to keep studying, and that's the only way you're going to learn it, is to study the code. So I think that we've done everything. I think we've got everything done. See, that said it was accuracy 83%. Before it said it was 80% accuracy. And so what I'll do is I'll save it. But I'm not going to wait for it to save and run, because it's going to be about 10 minutes to do that. And so I'm not going to keep you watching this video just to watch it save and run. That's a bit silly. But what I will do is I will put the code in the description box down below, where you can actually look at the code and study the code yourself. So that's it for this code review. Thank you so much for watching my video. I would like to thank my subscribers for supporting my channel, and I look forward to making more code reviews for you in the future.